This flood brings lot and lots of sediments, and these sediments are extremely fertile, and that's where our agriculture happens. It is that agriculture that created our civilizations. So we built a lot of highways uh, over our rivers, of course, and nearby rivers, but we don't consider the floodplains. Majority of our planning is done during the summertime, and we don't go there at the time of flood, so you do not know how much water is there will come. So they just build it as like the contractor will just come, they'll just say that this is the best design, you'll just build it, etc. But what happens is that during the time of floods, it will eventually that infrastructure will be affected. Thank you so much, Vanna, and everyone for having me here. It's really a privilege. I work in a particular team called Geoanalytics. I'll just explain what it is. So what I do is, from the last line of this slide, you can see that there is data analytics tools and models. I take it to the government, and so that the cities make planning and governance decisions that are both economically competitive and as well as environmentally sustainable. We don't want to give it like just like development projects, go and do it kind of thing. But we want to make sure that it is environmentally sustainable and also equitable. That is, make sure that projects don't affect a particular section of the populace, whether it is poorer population living in this place, that place, etc., etc. So we try to make sure that this is our vision for my team. Since last year, this has been our vision, and we have adopted it. And so, as I said, this is the approach. So I use a lot of satellite data. I use a lot of mapping tools. I use big data. I use models for machine learning, artificial intelligence. I take all of those from the tech side, science and tech side. And what I do is I build research. I build prototype tools. I build future scenario models, some policies, then also training program for government officials when required. And then we take it to the government. And what we are expecting from that is governments are taking information. I mean, they take decision based on information. Now, why I'm saying that it is decision is very critical when it comes to information is that if I ask you a question, like say, for example, do you think the number of trees have increased or decreased in India in the last 100 years? Now, unanimously, everyone will say that it has decreased, right? So it is a common thought. But the problem is it has not. The thing is, natural vegetation has decreased, but artificial vegetation has increased a lot, exponentially, because of agriculture, because of a lot of these ornamental trees coming in, and so much of it. It might not be environmentally good, but that is how it has been happening. So for a government, it shouldn't be based on any of these perceptions. That is, people imagine this way, that way, etc., etc. Instead of that, I think about informed decision making. So that's what I try to do. So this is the process, the entire process, how it happens. So first is in the left side, what you can see is a set of maps, set of data that comes in. This is just a sample we actually produce. When we are taking some decisions, we bring in around 100 to 200 layers, depending on the area and the team of work that we have. We bring in a lot of these data, figuring out what is happening where, etc., whether it is temperature is increasing or surface water is changing, vegetation has been changing, or it can be whether land is moving up or down, everything about that. We bring all these maps. And the second part is to figure out what is happening from that. And third is in the photograph that you can see, we take it to the government, and the guy is from, he was a planner and government planner, and he's doing planning, and we support him from our team and see that, these are the problems, these are the data, this is what solution you can take it. So this is how data-driven decision making works. And from that, I'll give the context of flooding in India. Now, when I say flooding, I mean, people generally believe that, rain comes in, it goes out, and that's it, floods, and it wreaks havoc, and they simply think that it can be controlled or anything of that sort. So actually, there are so many things into it. So I'll just talk about there are 5-6 types of floods. Actually, India is affected by at least these 5, which is the first one is the riverine floods. That, say, for example, huge amount of rainfall happens in the mountains, and the river just expands, and because of that, there is a lot of flooding, like what you see in Bihar or Karnataka or something like that. Or then there is pluvial flooding. That is, for example, you are living in a city like Bangalore or Mumbai. where it is not a river, it is just the heavy rains, and because of that, there is kind of floods. And then there are other types like coastal floods. For example, if a storm is coming, storm water, I mean, the sea level rises, and because of it, there will be floods. And there are other two types, which is groundwater and glacial lake. I'll just show an image for glacial lake in the presentation, but these are the different types of floods because each one of them requires different types of intervention. One solution will not address all the problems. That is the condition. I'll start with this map. And when we talk about India's riverine floods, we need to know about India's rivers and the river systems. So our rivers are extremely dynamic. That means their numbers, their flow amount, the quantity, everything changes with respect to seasons, like extremely changes. Sometimes if you see certain images of Ganga in certain places, in certain times, it will look like a small stream at sometimes, so during summer. But at the time of floods or at the time of monsoon, it will span kilometers. The width will be like multiple kilometers. So it's extremely dynamic. So historically, it has been very good for us in the sense, if you talk about any civilization, whether it is Indus Valley or whether it is Ganga, or why does it happen in the river valley, right? So it is because of this flood water. This flood brings lots of sediments, and these sediments are extremely fertile, and that's where our agriculture happens. It is that agriculture that created our civilizations. And so it is very critical for us to have these floods. It's not like flood is something that is evil. It is actually a very good tool for us. Now, because the lands, in some parts of it, we try to prevent it. You don't get, fertile soil anymore. That is the condition right now, because of which you have to use a lot of manure and everything of that sort artificially. But so this is how the river system is in India, and Ganga is the single largest. Nearly half of India's population is in the Ganga watershed. You can see it in the blue color. The large blue is Ganga, and other rivers also take up a good chunk of it. Now, as I was saying about how it changes between time. So here is a sample how it happened in this year. So this is critical to understand what is floodplain. So this is a satellite image for Bhima River in northern Karnataka. This happened in this year. So in May 2020, that is the top image. What you can see a small river. It's blue and it's flowing as per what we want during summer season. Maybe it's flowing through a channel, and you can see the land is appearing a little bit darker because of fires. Actually, people after they are done with the crop, they burn, right? So it's a little bit dark, as well as the soil is also black soil, by the way. So it's a little bit of both combinations. But so you can see a lot of agricultural land as it is, and that is the top image. But in October 2020, you have in the bottom image, what you see is that the river, there was a huge amount of rainfall upstream in Maharashtra. And because of that, there was a huge flood in Karnataka. And now you can see the size of the river, how it has changed. So this is a very small one. I just kept it because it happened this year. So, and I had a very good satellite image for it. So I kept it like that. But in case of Krishna last year, it was like 5 kilometers it was spanning. So in this case, you can see multiple kilometers it has gone inside, and many farmlands have been taken over by these sediments. So you can see the brown color because of the sediments that it brings, the soil, the fertile soil it comes with. So historically, these agricultural fields also have been acting as the buffer for this. So this is what we call as floodplains. That is, you have a smaller course for the river, but during the times of floods, it expands. And this floodplain is very critical to hold this flood water as well as to transfer it. Now, unfortunately, we think we have been, at least our engineers have been thinking in the other way around. We have been trying to contain the river into a smaller bandwidth, and because of which it is leading to further issues. So here's one case, what is happening in Bihar. So the Kosi River is one of the most flood prone, as they say, but here's the problem. So the government thought, this has been happening for the last few decades as well. So what they thought was, if you build walls on both the sides, the river won't expand. right? So for thousands of kilometers across Bihar, we have built all these embankments. So in the image, you can see that the river is following two lines. So that has been marked roughly. You can see the brown area is just contained within these two lines. Those are the embankments. Now, what happens is that because of that, the area within these two walls, they get overflooded. And the area outside the walls, the water from that is not able to enter inside the river. Technically, water is supposed to go to the river, right? So because it has been walled, this water also can't enter in. So that is what is marked in the yellow color. So you can see that there is a lot of water over there. All these are having water and they can never go outside. So unfortunately, I mean, in the normal flood situation, at least you will have 3-4 days of flooding and it will eventually drain. But in this case, it cannot drain at all. The walls are preventing it. So these are the embankment walls. And in the bottom, you can see that the embankment is not clear because, sometimes other rivers come in. So your wall is not complete, or there is a small town by the river or something like that, because of which the embankment has opening. So basically, the embankment has not stopped the flooding. It has just transferred from one place to another. But eventually, people are still getting affected. But this is what the problem with our engineering solutions. Instead of controlling it, it became like hundreds of different kinds of problems. So here's a zoomed in version of it. So you can see that this is the red color line in the top image is the embankment. And within the embankment, you can see some villages which are completely drowned because they have built a wall and the water cannot go outside. And instead of 1 feet of flood water, now you are having 3-4 feet. So you're just so this is the reason why Bihar floods every year. It's not because of abnormal rain. It is because of these kind of issues. So in the second one, you can say that an embankment has failed. Now, this is also a problem. When you have thousands of kilometers of walls, someone has to maintain it. If one person forgets or one person leaves it, that's it. It's broken. And it eventually leads to failure. So this was this year again. So you can see a failure, and because of it, many areas were flooded, and it was like that. So one of the worst cases happened in 2008 in Kosi River. So what you see here is the animation of before and after of it. So you can see a huge yellow line in the middle of it appearing, right? So this is because this is hundreds of kilometers, by the way. So when the embankment failed in 2008, people blamed again on rat holes and foxholes, whatever it is on those things were blamed on. And eventually it began killing hundreds of people as well as flooding a lot of lands. And the water was also not able to go back to the river because, again, there is a wall in another place. So it was this kind of an issue. Now, that is one aspect of it when we try to control it. The second aspect is when we try to build over it without respecting it. So we build a lot of highways over our rivers, of course, and nearby the rivers, but we don't consider the floodplains. Majority of our planning is done during the summertime, and we don't go there at the time of flood, so you do not know how much water is there will come. So they just build it as like the contractor will just come, they'll just say that this is the best design, you'll just build it, etc. But what happens is that during the time of floods, it will eventually that infrastructure will be affected. So this is in the right side. What you see is Kabini River. Yeah, this was from last year. So in the top image, what you can see is flooded areas as per satellite image from radar images. And in the bottom image, you can see Google Maps, which says which are the places that have been blocked because traffic has been blocked because of flooding. So what you can notice over here is exactly in the floodplains, these blockages have happened. It's primarily because the roads were not built when you're trying to build over a floodplain. You have to make sure that culverts are in place, etc., etc. But even though our engineers do know that, they do not know where the floodplain is, right? So that is the biggest problem. You might know what is the solution for it, but you do not know where the floodplain is. So this is the worst part is when it happens in urban area, it will be even worse. Like say, for example, this is the Bellandur Vartur area in Bangalore. So in the left side image, what you can see in 1984, that area marked in the red circle, that is a floodplain between these two lakes. So when the Bellandur lake overflows, it will flow through this region and it will go to the Vartur lake. Now in 2016, you can see that all of this have been built up and a small canal has been left for water to run. Now just imagine how it is going to play, right? So what we did was in a few years back, we created a model to figure out, where exactly are these floodplains in Bangalore, and how has been urbanization, that is building growth, has been happening in Bangalore. So in the right side animation, what you can see is in the green color are areas which are demarcated as floodplains by us. It is not a government one. We've demarcated it because government doesn't have any information on this, right? And then using satellite images, the gray color and red color, what you see is how buildings grew in Bangalore. So you can see the city expanding over time in the last 25 years. And you can see that some of the areas in red are where floodplains are, where they have constructed buildings. Now, of all the white areas, of course, you can build over there. That is good. But unfortunately, our real estate business doesn't work that way. They think whatever is, if this place is developed, take the nearby next place. They don't look at floodplains. They don't look at anything else. And it has just expanded just like that. And in the last 20 years, as I said, like Bangalore has Bangalore, the problem is Bangalore is sitting on the top of the hill. Unlike other cities, Mumbai or Kolkata or Chennai, where you are like, at the bottom, Bangalore is in the top of the hill, but it floods over there, right? So it is that kind of a problem. So you can see over here. So 3 photos I have taken from news media, and from our map, where are these photos taken, etc. I just put it over there. So you can see that all the 3 are falling with the red areas that we have marked. So it is a poor planning practice. That's it. So one is from Bellandur Vartur, one is from Electronic City, the other from Koramangala. You can see all these flooded. It's not just about water being stagnant or you are not able to buy groceries. You can see the cars over there that are standing in it. That means insurance, money. There is a lot of money that is involved, and money is being lost just because of poor planning and poor execution of these things. So and beyond that, we also have infrastructure related issues. That is, when we say about, they build canals, but are these canals really useful? That is another question. So you can see in the top image, satellite image from Bangalore, this one again from Bangalore. In the top one, you can see it like a canal has been made to turn 90 degrees. This is not how a river flows. River flows in a natural way, but our plots and buildings, they wanted like 90 degrees and everything. So they just built it just like that. And the worst part is now the canal is carrying sewage water. That means when floods come, some amount of the capacity is already gone because sewage is flowing in it. And the next 2 images are photos from Bangalore again. So you can see the way our engineers think about these things. So in the left side, what you can see is a photograph of a stormwater drain in Bangalore. You can see that it is raised by 3-4 inches from the road. Basically, water is not going to enter in unless it fills 4 inches. But why they have done it is, according to them, they will not get the project in the next few years. And for next few years, the road height might increase. And after that, the water will flow automatically into it. So for the first 4 or 5 years, you have to just witness that. It depends. Next time when they come in, they have to change it again, etc., and those kind of things. This is not working at all. And in the right side, you can see how the existing stormwater drain is, blocked by all our solid waste, etc., etc. So you have a lot of these problems happening in our city. So my duty is to figure out, right, like where it is happening. So the last one, this is one type of flooding that I promised to talk about a little bit. What is it? It is a glacial lake outburst flooding. Not much people have introduction into this section. So what happens is that our glaciers have been melting, and particularly they have been melting at a faster rate. And because of which there are many temporary lakes that have been formed near the glaciers. So this case is from Sikkim. So the yellow line marks, the size of the lake in 1968. Now the red line, you can see that it is 2020. It has been growing every year. And this is a temporary lake. So at any time it can burst. Once the edge of it cracks, once it is not able to hold the amount of water, it is going to break. These are not permanent, by the way. But we do not know when it is going to happen because you need to check how stable it is, etc., etc. When this happens, a lot of lives usually get lost in other places. So, but we are going to face this type of floods, but I'm not going to go into this because it's the solution part of this is a very complex one. We still have a lot of solutions back in our cities and other places itself that requires intervention. And so this one, it can wait a little bit. Now, with that in context, what can we do? So I have a few slides over here that talks about the solutions of solutions that we can take up, etc. So the first one is data. Now, this is the biggest trouble that we have. When I say data, when we want to know which are the places that are going to be affected, we need to know what is the terrain like. We know water is going to flow from top to bottom, etc., etc. You can think about all of these things. But do you know what is the top and what is the bottom? Do you have the elevation data for it, etc.? Now, the government has a course data that is already out there, which can maybe help out a little bit in, say, riverine conditions, in big rivers, etc. But in our cities, we don't have very high resolution data. Even if it is not much used for any of the analytical process. I know for sure that there are some data in certain cities, but not all cities. So here in this map, actually you can see a 3D terrain that I built out of satellite images and everything for Mumbai. Now, when you see this itself, you can figure out where is water going to flow when the rains come in, right? So this data is critical. Now, this data is something that government has to build. And as I said, we have coarse resolution, but we need to make it more final. Now, for example, Google is working with the CWC, that is the Central Water Commission, with one of the flood-related projects in Brahmaputra River. Now, they have complained that that they don't have good accuracy elevation data. That is, they do not know the terrain very well. So they procured satellite images and they began creating higher resolution versions, but that is only for Brahmaputra. And that is again Google, right? Our government need to figure out things for ourselves, right? We need to do it. We have our own capacities in ISRO, NRSC, we have it in SAC Ahmedabad. So there are capacities in our country. We need to increase it. So from this aspect, I'll just talk about how we are going to do it. So first is we need that elevation data. We need to spatialize all the data that is there. We need to talk about where water will flow, what are the places which are having buildings. Even now so why I'm stressing a little bit on this data front is that, see, we do not have clarity on how many villages we have, how many lakes we have, how many rivers are flowing in our country. We don't have clarity. We have, rough numbers, but if you strictly ask any person, any expert, even myself, I mean, if you ask it, I'll just give you an approximate number. And this is the number, etc., or something like that. If you ask me in depth, I'll be like, this is what it is, but we are not sure. There might be small problems here, there, etc., etc. That kind of an explanation. We do not know. We do not have a proper urban land use maps. We don't have anything around this kind of situation. So this is a very tragic situation. This is a very tragic situation, and because of which we are not able to take decisions. When you go to the local governments, you will see that these lack of data is affecting all this analysis. Now, the second solution that I want to talk about is capacity building. Now, let's say that like the model that is showing in the right side. This is a simulation model because I had data. I created data for a particular place, and in a particular place I can run it. It requires a good computation power, but maybe I can run it. But if I have to tell this to a government official who is going to work with a corporation or a state government or something like that, does he have the capacity? Right? So software, do you have the person to sit and work on it? So these capacity building is completely lacking. We need to finance this. So we are not doing it right now. Now, once you do this, after this, we can create maps of hazards. I mean, it's not just the simulation that you're seeing on the right side. So that is one-time flood simulation. But with that, we can create a map saying that this place is likely to face floods once in 5 years or once in 10 years, etc., etc. which we can use in our planning process. So US has it, the United States has it for the entire country. But we don't have anything in that sort. So this flood, the flood zoning mapping in 1975, CWC around 1975, they came up with an idea for it. And till now, there is no progress in it. There is absolutely no progress in it. That's a very sad state of our affairs. So we don't have this. So we need money for doing this, and it is not there. Since it is not there, then the maps are not coming out. Since the maps are not there, the planning processes are not happening. Now, why I want this maps to be shown is that if the maps are out there, then banks can take it, insurance companies can take it, and they can say, don't build it over here, because if you build it, I won't be able to provide insurance for your house. This is a high risk area. Why should I fund it? Because the bank will be losing money if they want to, if they are going to fund all these things. Now, apart from this, there are other methods to avoid all these problems. So, say for example, if I'm going to tell a particular farmer that, your land is a low-lying area and you should not sell it to anyone, what will happen to him? He also wants to take part in the economic development, right? In the sense, like, if I'm going to if I am going to sell land to a developer and build an apartment and rent it out and make money, why shouldn't another farmer, right? So since he's in a floodplain, etc. So to avoid that, we have some schemes called land pooling and town planning schemes, so that they don't get disadvantaged because they are near a floodplain. And finally, that there is water sensitive urban design. I'll just show 2 slides on these 2 aspects of it, the solutions, for which again we use a lot of data. That is, for example, this is on this is an illustrative map, I can say. So this land pooling schemes is one of the things that we do a lot in WRI. We are again helping the government with the Amrut scheme, and in that also we have been telling them how to do it, etc. So in India, land pooling scheme in Gujarat, they have done it a little bit, and but it is still not very widely practiced. So what is land pooling scheme and why it is critical is that in the left side, what you see is, the current situation, you can say. Some village roads are there, a small village is there, some farmlands are there. You can see that each parcel is there. Each one is owned by a different person. And in the second image, this is what we do right now, is that we want to put a road or something like that, put a development. And you just build a big road in the middle and you compensate for the land that is taken out. That is what we do right now, right? This is how it is working. And you have to spend a lot of money on this compensation. And the parcels are still out there, and some of them, so after that, everyone sells to another person, this person, that person, and rapid unplanned growth happens. Instead of that, the option 2 in the right side image, what you can see over here, is land pooling scheme. What we do is, we take all these farmlands as a single entity and redistribute it, rearrange it, and figure which are the areas that have to be protected as park, which have to be protected as agricultural land, which have to be protected as natural buffer against flooding. That we create, and you have better roads, you have better. Now, land is a little bit lost here, but value is not. Value increases. Imagine in the first option, if you are just doing land, acquisition, what happens is that you don't have any other service. So here, of course, the road is nearby, you can get a higher amount. But imagine a land which is well serviced. That is, you have a park, you are well protected against floods, you are well protected against heat, and your transport system is proper. That means your land value is going to be even higher. So even though you might lose a little bit of extra land because you are going to build a proper network, you will not lose value. So that is land pooling scheme. This is now practiced in Gujarat, and in also as part of Amrut also it has been practiced. So why don't we do it for the entire country, right? So that is the critical aspect of it. The next is bring water sensitive urban design into this. In urban areas like Bangalore, etc., we are just building concrete. We are just putting tar everywhere. We don't have anything that is that takes in water, sends it to the ground, which can reduce the amount of flooding. So this is what we call as water sensitive urban design. And you can see some of the examples from elsewhere. So why I'm saying is that you have a large parking lot, you have a, say, a big bus depot or something like that. And you right now everything is asphalted, everything is concrete, water doesn't go inside. Instead of that, we just can have a little bit of bioswales or small green interventions that allows you to at least reduce flooding by 10% or 15%. So these 2-3 interventions, these are not very complicated. So the reason why I'm focusing on these is that these are not complicated. I mean, you're not going to lose money, you're not going to lose a big thing. It's just a matter of idea, a new idea that comes into place. Now for these and all, I normally I have a lot of maps, but yeah, considering time and everything, I'll just keep it short. So this is how we we can reduce a little bit of flooding. First is understanding why it is happening. Second is figure out what are the places where it will happen. And third is in each place, what will be the exact solution. Now, there is no single solution for the entire problem. So, but it can be always created. The solutions can be created if we bring in the data. So to do these, we need to finance our institutions, like, say, NRSC, SAC Ahmedabad, to figure out the maps, create the maps. We don't have it right now. I've been talking about it for many years. They are asking, why don't you prepare it, etc. But I'm not the authority. I can prepare it, but who would follow it, right? If the government does it, it's a bit better. So we have been always telling, like, government should be doing it instead of us, so that it can be taken forward. The first iteration, of course, it will be difficult, a little bit difficult to understand these concepts. But in the second one, of course, it will get better. Over 3-4 years period, it will always get better. So, so this is my presentation, just giving you a little bit of context. The flood story is a big story. You can find a lot of it in my tweets if you want to, where I talk about individual cases, what is happening. So it's case by case, we have to intervene, where the local government and the state government, everyone has to partner and figure out whether it is a flood happening in Dehradun or Bangalore, or it doesn't matter. So that is that. So anyway.
Meantime, I would like to ask you two questions. One is regarding the urban planning of Bangalore that you were discussing. And in fact, Kosi River also, the embankments on Kosi River. I believe all these must have been prepared by civil engineers in the government, approved by somebody in the authority. And now the authorities only are trying to manage this. How does it work?
So I thought of keeping one slide on this Bangalore planning one, but eventually I took it out. But so the Bangalore master plan, the RMP 2015, that is the regional master plan of 2015, which was prepared in 2008. Around that time, it was composed. So back then, the scientific understanding of floodplains was not there in the community, let alone the planners. Right? So it was not there. And there were not enough tools. And so what they have done in the plan is that they took all the drains, and around that they drew buffers, 10 meters, 5 meters, blanket buffer. In some places, actually, you don't even need buffer. In some places, you need a lot of it. But they put blanket buffer everywhere. And it is not being respected. That is a different story. But that blanket buffer is going on. So that is currently still there because the new regional master plan has not been finished because of a lot of criticism and everything. It is being redone. But the current regional master plan doesn't have any provisions for it because of the lack of understanding in the past. So this is how we work. The 15 years once master plan is being done, the technology and the science would have, exploded a lot in the meantime. It's just 7 years. When I joined WRA India, it was 2015, and I was showing them the master plan, and I was telling them, this is not how you do it. But planners did not have any idea, and these planners, of course, as I said, the capacity is lacking thing. But planners sitting in at the age of 45, 50, talking about new softwares, it's very difficult. So they need some juniors, younger juniors who can take this up and do it. But that has not happened in the past. So that is with the Bangalore story. In the Bihar story, it is a very complex process. So that the Bihar one is it is not a regional master plan or anything of that sort. Engineers started it. I mean, this was started in the British era, and they started it, and they have been just going with it. And nobody wants to break the status quo. The fear is, I mean, is what we call now power without responsibility. Like I am like, I can talk about it because I'm not responsible for, if some flood happens, nobody's going to question Raj. But the engineer over there has a fear that, if I change something and because of that, something else has happened, then they will all come to me. So that fear is there. So because of that, they are not going with change. They don't want to change. Even if it is good or bad, they don't want to do it because they just let it be. I mean, every year they'll criticize me one day, but instead of that, what if they criticize me every day and put me in jail or something? So because of that, the engineers are not doing it at all. There is a legit fear. I mean, this is a legit fear. I mean, even if I am put in over there, I'll be having, I'll talk about these, but it is very difficult for them to make the change since the responsibility is with them. So,
what a fall, Raj. I was thinking from Dholavira. I was in Dholavira same time last year. 3 layers of water channels built, taking into account the height and all of that of the entire region. So what a fall from that time. I was wondering, all of that drained into a big canal outside with several wells which all get filled up through the entire Dholavira city. Beautiful design. It was like jaw-dropping, to be honest. Anyway, so my question was around Bangalore. What do you do now or Mumbai? We are where we are. What do you do now? I mean, the slide that you showed on, small open spaces in parking and walking areas, that's probably not a solution at this point in time.
So the water sensitive urban design is a way to reduce the impact. It is not going to completely answer it. See, the problem is the floodplain have been already encroached in Bangalore, and right now, the rough thing is, if you want to demolish every house, of course you can go and take it. It will solve the problem, but people have invested a bit in it. So there is a lock-in period. It's at least a 30-40 year period that they look into when they build an apartment or a house or something like that. So it is very difficult in that perspective. I mean, for the already developed areas. But what I wanted to stress is still new areas are being developed, which is not following any of these. Old areas, that is a headache. We have to figure out some complex solutions for it. We do have some of the thoughts in it. I'll talk about it a little bit. But before that, even in the new areas which are coming up, it is not being taken up. That is the problem. Now, there is a peripheral ring road coming in. There is a lot of development across the Sarjapur as well as the airport road. None of these plans or any of these schemes or any of these protected ones. So what I'm going to have is, right now, let's say the 100 acres is flooded. Next year, I'm going to explode it into 150 acres. It's going to happen. So already existing one, at least I can maintain status quo. 100 itself can become 100, right? So, but now the thing is, that is why I was focusing a little bit on greenfield development when I talked about land pooling schemes and everything. Greenfield development, that is new development that is coming in. At least they can accommodate all these things. Because the lock-in period, since it is high for the already developed one, it becomes a stage-by-stage development. We call it as local area planning. We have put that in the recommendations for restructuring of Bangalore. There is a document you can find online called, you can go to a website called bbmprestructuring.org. Right now, government is still taking bits and pieces of it, but Bangalore is very messed up when it comes to civic society, politics, and everything. It is honestly, it is messed up from top to bottom. Because of which there is a little bit hesitance in kind of decision making around things. Whatever someone wants to do, someone is going to oppose. And so that is the reality. So from that, actually, we talked about this levels of planning and particularly local area planning, which talks about how over time you can improve the already problematic areas. When they are rebuilding, what should be the regulation? Now you can't go and demolish the houses. There are lakhs of people sitting over there. So we can't demolish it. It's not fair. I mean, even if it is, even if we think that we can demolish, if the people accept also, you have to pay compensation. That amount is not going to come. So what we are thinking is planning regulations for already developed areas in these, how they can build when they are, rebuilding it. Once after 20 years or 30 years, when they are like done, what should they do? So that is so there are two types of one. In this one, I focused a little bit on greenfield, but this brownfield development or redevelopment is something that we don't talk about in India because of the contentious issues. I mean, anyone, you are going to tell a public like, your house is in a very bad area. If I give a solution to them, they'll be like, are you going to demolish mine? Right. So immediately there will be a protest or something like that. But so that is a little bit complex and a tricky one, but we have put some recommendations for it. There are two, as I said, two types of recommendations. One is to prevent from it to happen. Second is for the already, done area, what is the solution? So I a little bit focused on the planning for future development, at least, because we are still going to expand a lot. So at least that you can reduce. That is the concept.
Is it a lack of competence within our technical circles in the government, or is it a lack of political will, or both?
Complex, all of them, plus fear, personal fears. Nobody wants to take the risk. I mean, we have, I don't remember how many commissioners for Bangalore we had since 2015. But I think at least 3 or some Manjunatha Prasad, I don't remember, like 3-4 people are there. But each one will be like, they want to do it. They personally, they might have that. Technical competence, it's usually like a problem with respect to finance. If finance is sorted out, then technical competence will automatically come into place. New ideas will come in if they are having the funds. I mean, of course, as I said, like, we can't expect everything to happen with the, already the big planner. I mean, the say senior planners or something. But that technical competence can be solved. Political will is usually, I think that whether it is Congress or BJP or anything of that sort, usually I think that there is some kind of a will. But it doesn't necessarily translate because we have a huge bureaucratic setup. We have a huge set of officers who take the decision. If you ask whether a chief minister or even the prime minister, if you ask it, like, they would have their opinions. They can try push it, but at the end, the documents, the papers, and everything is officers. So at that point, they might not. So it's a political will from the point of view of a bureaucrat that is affecting it a lot, and they have a fear. Everybody has a fear. I mean, I bring in all of these things. They always say that, we can try piloting it, we can do it, we can, but never happens. So fear is there.
I have one question for decision making. Do you use data science techniques to analyze your data, or you are working on only qualitative data?
No. So we work on every aspect of data. So I didn't stress on the methodologies that we use because it's a little bit complex. For example, when I say we use data, what kind of data we would be using, I'll just give a glimpse. For let's say for Bangalore, if you are going to again for Bangalore, we can say we will try to get all the satellite-based estimations. Well, there is a huge reason why I prefer satellite-based estimations, because it is not coming from specific people, right? So I know what is the problem with that machine. But it's a machine that is going to deliver, and it is not having any bias or anything of that sort. And it comes to me in raw. So I prefer a lot of this satellite data. So we use a lot of satellite data to figure out elevation. We try to figure out where buildings are, what type of buildings are there, whether it is residential apartments or whether it is commercial buildings, etc., etc. We have models for it. So we built that in one side of it to figure out what is there on ground. That is one aspect. Second is for the socio-economic factors, we use a lot of census and a lot of data from the government itself, whether it is census, primary population census, or it's the socio-economic and caste census, or the economic census every year, the ASI data, the directory of establishments. We bring in a lot of these kind of data as well. And we try to specialize and we try to figure out about the quality aspect of people and their amenities that they have. That is, say, for example, if I want to talk about, sewer system or something like that, I want to know what is the percentage of houses that are having connections over there, right? So for that, I'll use satellite images, I'll use census and other survey data, as well as the engineering data that is coming from, the respective department, whether it is for Bangalore case, it is BWSSB, Hyderabad HMWSSB, etc., etc. So that is the Bangalore Water Supply and Sewerage Board. So they will have their pipelines data. We bring that in. So we try to figure out and we make sure what is happening on ground should be captured in our computer. That is the biggest aspect of it. Most of my time is not with the interpretation or with the political parties. I've been more going into the science and research of it. What we do mostly is that we try to, in my computer, I need to have the representation of what is happening in Bangalore. Entire Bangalore should be in my finger. That's, in the sense like to analyze it. If I want to know who is where, so basically to understand the questions of where, who, what, why, these kind of questions, if I want to answer anything that is coming as data, I'll take it. So it is not necessarily qualitative, etc. And we do a lot of analysis. We build a lot of models. It can be a simple linear regression. It can be AI. And for this example, that simulation of flood model that you see over here, that was coded in Python. It was a specific program we call Lisp flood model, and it's a cellular automata type of a model. And for figuring out what is a flooded area that is already affected, not modeling, for those kind of things, we use machine learning and AI. So we use a lot of analytics. Data forms the crux of the entire process, and we spend a lot of time in digitizing. Right now, I have 9 people in my team to sit and digitize data. Then we have 2-3 programmers, including me. We model the data, we structure, and we bring the stories out of it. And we make sure that everything is represented on, like what is seen on ground is represented in my computer. That is the aspect of it. So I think once in a while I make this comment in Twitter also, like, see, with all these softwares and everything, anyone can prepare map. Map preparation is not a tough task. If you open certain websites, anyone can prepare maps. But to understand what you're preparing is the hardest part of it. So for that, we use a lot of analytics. Unfortunately, in our presentations, we don't bring those ones because when we are talking to a politician or general public, it becomes difficult to explain the statistical models. So the first presentation when I had was I took to when we were meeting the commissioner of Bangalore, and I had prepared like a statistical numbers, and huge number of numbers were there. And my boss was like, do you know what you're doing? This is the actual numbers. As I got it, I'm just showing you. The politician cannot read more than 2 numbers in a single slide. So trim it down, trim it down, trim it down. Now, this is my current version of after all those trimming downs. So, but anyway, we have a very good set of analysis and models. As I said, we have one of the best teams in the country to do this right now. We are building it also. So last year we had 3 people, and now we got funds because people saw success in it. So now we have 15 people working in the team. And I'm expecting it to grow to 30 people in the team. So, just from my perspective, just from my team itself. So this is the big expansion and everything. So that's because of this pipeline we have from data till interpretation. Off recently, I have not been conversing much with the political or the governance side. I'm more and more going into the data side and sit and I just want to enjoy my own time kind of thing. But that's how we work. I hope it answers your question.
Do you put out these animations, these visualizations online, apart from Twitter, on any other channel where, I mean, anybody can come in and read them? Like there is a site called datastories.in, for example. Do you do something similar, open source them?
So yeah, so what currently, as I said, like once our Twitter, when I think I cracked a little bit, I guess. When I sent maps out, people were reacting very well, and we got some funding also. So right now, what we are doing is at least 2 to 3 people in our team in 2021 in particular, they will be building a particular site for us. There will be a particular website where, so far in Twitter, I have shown the byproducts only. Not the stuff that we show to the government. Okay, so this is more. So in my Twitter account, I would have put it like, it's personal. So byproducts, I share it over there. So this is just the byproducts what you're seeing. So the actual analysis and the maps are like really intense, and we want to make sure we don't put it that much outside, because sometimes it's also our own thing, right? We want to show it to the government and that kind of. There is a tactical reason for it. But now we have funding for it. So what we are doing is, actually there's a team, 2 to 3 people are there right now. They are sitting and developing this website, which will be custom made for showing these kind of maps and stories. It's not just data I want to put it outside. So I've been very clear about it. Data for the sake of data is useless. If you go to any other website, you can find a lot of data people can download and see, but I want to make sure that it's useful. So we are creating a website. We have from our team, there will be people who are arranging it, as well as there will be an external consultant to design the website and everything like that, where we will be putting out a lot of these things, which anyone can download, anyone can access, anyone can filter it. If you want story by city, that is a huge problem that management is having, because there is 16 TB of maps in my computer and hard disk. So we are trying to figure out how to bring it out without costing too much for the company. They are like, do you want me to build this much amount of a website or something? It's a question, but slowly we are trying to solve it. So yeah, it's actually going in a good direction. I mean, taken all these, many people ask the same question online also. So management took it. It's the first step. Let's see. So we believe that more funds will be coming in, and once that comes in, we'll build a better storytelling website. So anyone, I believe in storytelling. I watch a lot of this wrestling and everything. So I believe in storytelling. That is, a map shouldn't go just like that. There should be a story with it.